Hey guys, welcome back to the Zeus Developer channel. This is a short series where we're deploying Kubernetes cluster with Amazon EKS, that's Elastic Kubernetes Service. We've had two videos already. The first where we deployed the cluster, right, and ran a sample Nginx application. The second video was where we set up a load balancer, so we could access our app, from anywhere. We set up Ingress, right, and also tried the network load balancer that AWS automatically sets up when you create a load balancer type service. But in this video, we want to take things further by setting up external DNS controller, and that is a way to connect your domain name to your application so that you can access your app via your domain name, right? You saw that the last video we had to use AWS gave us a very long URL. What if you want to connect your domain to your app? And that's what we want to try to do with the help of external DNS. So external DNS is basically a controller. I'll explain what the way controllers work with Kubernetes. They are basically tasks. They watch services, or they watch processes, right? In this case now, it's going to watch your ingress or your service, all right, in your cluster, right, against an AWS service, in this case load balancer service, all right. So as soon as your ingress or your service changes, it informs or updates your AWS service. In fact, in this case it's route 53, all right, because that's the DNS service that manages your domain name in AWS. So that's what this controller does. So I've gone ahead to bring the domain name I want to use to route 53. It's let's look at it here. It's a simple connection. You know how to do that. Just basically, when you create a hosted zone, AWS gives you, route 53 gives you NS records. Just take those NS record and connect it to wherever you have your domain purchased or registered, right? That's what we've done. So look at the domain here. If I open it up, you will see the NS records, and I've created the records in my domain with my domain registrar, right? So this bit it's good. But before we even go further, let's see where we stopped last time, where we created Ingress, and then AWS gave us a URL for our app. Let's go look at that again. Make sure things are good, so that we're continuing from there. All right. So this is the load balancer URL. All right. Remember. So we'll take this and try to see if our app is still intact. It's a basic example Nginx web server. So we'll go to HTTP. We missed the M. All right, so our Nginx app is still intact. Now, what we want to do, we want to be able to go to this domain name. All right, we want to be able to go to this domain name and be able to access this service. All right, let's try it at first. Let's see what it gives us now. If we go here, see, site cannot be reached. There's nothing happening here, right? Let's make sure. Okay, yeah, it's HTTP. So hopefully when we finish, we'll refresh this, and then we'll get our app or this Nginx page showing here. That's what we want to achieve in this video. So what do we need to do? There are a few things we need to get done. All right. As with any controller, the first thing you need to do is to set up authentication. So we've created a policy, created a role with that policy, and added the cluster provider URL as a trust. All right. just like we did for load balancer. So I've already done this. I can show you the role. This is a role here we're using. There's a role here, and this is the policy here. That's because it's basically policy for Route 53. So your Kubernetes can talk to your AWS, right, to create records for you. That's what this policy is meant to do. All right, so we've created the policy. Is a short policy. Let's see what next. So I've created the role. The role is intact, and I'm going to use that role for the creation of a DNS controller. So that's the next thing. That's number 2. That's where we're starting from. So we're using Helm, again, a package manager for Kubernetes to install services, install controllers, and whatnot. So what we need to do is to create install this controller using this guy here. And then number 3, we're going to update our Ingress and add a few more things. All right, we're going to add a few more things to our Ingress, and when we check again, we won't be seeing that long URL. We'll be seeing our domain name that we've specified. All right, so let's continue with number 2, which is to create the controller with Helm, right? So again, this is the policy here. It's a short policy. We've created the role. The role is intact. I've copied the role URL, ARN, and all. All right, so we're creating this controller with Helm. We're doing Helm install. So there are different ways to run Helm install, right? You saw how in the other video we passed a bunch of set value, right? Now if you have a lot of values to set, the recommended way to run Helm install is to put those values in a file, all right, and pass that file, with the values flag or argument, right? So, and that's what we want to, because there are a bunch of arguments we need to pass. So in this case now, we're not using set. All right, yeah, we have a single set here, but the rest of those values, we're going to pass them via a file. All right, I'm going to show you the file now, and then we're going to run this Helm install command. And remember, it starts from here, right? This is the repo. I've already added the repo. We can only update it. This is your repo name. Let's just we're going to call it I'll call it ExternalDNS also, my repo name. So we're going to run all of this. Even here, it's supposed to be I'm going to call everything ExternalDNS. Even my release, I'm going to call it ExternalDNS. So we're going to run this guy here first. I'm going to show you the value file. Hold on. Let's add this repo. It's already added, but let's just see again. Already exists. Did you see this? All right. So what we can do maybe is to run update. So repo is good. So let's now to run this install. Again, we're passing namespace. This could be a single N or namespace. So we're installing this guy in this namespace, kube system namespace, and we're setting this value, service account annotation, because Helm here is going to create a service account, and that is how your Kubernetes has access or authorization against your AWS service, in this case now Route 53, right? So you're authorizing Kubernetes to be able to perform an action against an AWS service, in this case Route 53. So you would have to give it those permissions, and service account is how you get that done. Again, I'm going to do a separate video talking about AWS and Kubernetes authentication and authorization, how they work together. All right. So let's look at this values file. We have a bunch of things to set, right? That's why we're using a file. We're not using the set flag. So we're setting provider, it's going to be AWS. We're setting source, Ingress, because we're using Ingress, right? We're a service account. We're giving our service account a name. If we leave this out, of course, it's going to create service account with a name that we may not know. And policy here, all of this we're going to set. Domain filter is the domain name where we want it to watch. So all of these values we've put in a values file. Let's look at the values file. This is the file here, like I just mentioned. These are the values. All right, it's a YAML file, so all of these values are put here. All right, we have even more values: interval, 1 minute, log level info. Some are not necessary. I mean, it will be set by default, but these are the key ones. All right, we set, so we have this value, so we can run that command and hopefully get things installed, get the controller installed, right? So let's now take this and run this helm command. Hope everything is intact. Yep. Going to clear my screen. So it's going to do a bunch of things. It's going to install or set up a controller. Okay, I'm having an issue here. It's saying, right, because it's going to create a cluster role. The cluster role with this name already exists in this namespace, so I'm going to try to delete whatever exists. So I'll take this guy. I'm going to delete a cluster role. Cluster role deleted, and I think there is a cluster role binding that needs to be deleted too. That is called viewer cluster role binding. It's called ExternalDNS viewer. All right. So if I do this, we should be good to go. All right. Yes. The role and the role binding have been deleted. So again, this we're not going to talk about these things here. I will talk about these things in the authorization and authentication video. So let's clear and run the Helm install again. Hopefully this time things are good. All right, it seems so. Again, it's going to run it's going to create a deployment. It's going to create a service account, role binding, a cluster role binding. It's going to do all of that, right? So what's next to do is to we've done this. Number 3 here is to update our ingress with host name and host name annotation. So in the rules section here, we're just going to add this guy here. All right, so it's either we're using the primary domain, or we're creating a subdomain, however you want to do it. All right, we can try anything. So we'll take this guy and this guy. Let's let's copy both, right? And we annotate the host name as well, whichever domain you're using. So let's grab these two guys, open. Okay, let's do it one by one. Take this, we'll use nano to open our ingress, remember? And over here, this is how we left it, right? This is how we left it. So let's see if we can add it here. So this guy, yep, I think we should be good here. So we're using demo, or should we use something else? Let's just call it EKS, right? So again, what the controller does, all right, is to watch your ingress. As soon as it sees that your ingress has created or updated a new host name, it would tell Route 53, all right, because of course it has the permission. It will tell Route 53 to create that record, right? You will see what will happen. You will go back there and see that this record is created, and then we can access our Nginx app via this subdomain. So we've added this, and then we'll do annotation, right? We'll go copy that annotation and put it here. So we'll take this guy. All right, again, we're using EKS subdomain, right? So let's go. So we should be good. So this is all the updates or changes we need to do on our ingress object. So let's save this file, write out and exit, and apply it. Control apply the ingress, and if everything is good, we should have our ingress configured, more like updated. So we hope that things are working behind the scene. Now the controller, as soon as he sees that your ingress has been updated, it will inform Route 53 to create this record, right? So let's begin to check. If we now check our ingress again, we'll in a while now we'll begin to see our subdomain. Yep, we'll see our subdomain here. Great. So is it accessible yet? I don't know. So again, this, we're using EKS, we're using a subdomain, right? Sometimes I was going to say they take a couple of minutes, but voila. So if we go to our Route 53, you will see that this record has been created. Where is it? Route 53. Oh, yep. You saw these were the only records. There were just two records. This is a namespace name server record. So if we refresh here, we'll see that this subdomain record was created here. That will be a CNAME record, I think. Voila. So yep, our EKS subdomain record. It's not a CNAME. Okay, it's an A record. This is because it's mapping to the the load balancer URL, right? So it's an A record, and of course this one is for IP6. All right, so this was a short one. You've seen how we connected a domain name to our application using the external DNS, right? So going through the steps again, create a policy, create a role with the policy, add the your cluster or IDCD provider as a trust principal, and then you create the controller with the use of Elm, right? You can do this by yourself if you want. I mean, it's not hard, but you could use Helm to make things simple, right? And pass. What's important here is passing all of those arguments. If you don't have this intact, you're not going to get things working, right? You pass all of this, the service name, because this service name is also required in your role, right? So policy, zone type, text owner ID, that's the cluster name, domain filter. Some say this is not necessary. So if you don't pass domain filter, it's going to be watching for all any domain, right? But in this case now we're telling to watch just our particular domain name, right? So when you do that, you're going to have your controller created, and after that the next thing is to update our ingress, right? Update our ingress with the host name and a new annotation. All right, so yeah, we did eks.domainname.com, and then the annotation too, we made sure it's pointing to the same subdomain. Maybe we should look at the ingress again. No, sorry, I want to look at ingress, not. These were the annotations we did for load balancer, right? Again, this ingress is of class ALB, that's application load balancer for EKS. This is what we added here, the subdomain. You could as well just use your primary domain without having the subdomain. All right, and again, we're using the index path. So yeah, you could be anything. You could say /nginx, right? Meaning that to access this service, our application would have to put /nginx at the end of our subdomain. But we're using the index here, and of course it's mapping to our nginx service. This is the name of our nginx service that we created, that is still running here, and it's at port 40. Let's look at that as well. This is our service manifest, very short file, right? Look at the name here and look at this port here. That's what you take to this guy. So these two things must match. So again, Ingress works with either a ClusterIP service or a NodePort service. If it's a load balancer service, Ingress can work with it. AWS will automatically provision a load balancer for you. All right, again, this was a short one, and the next one we'll be able to see how we can take our we can create a multiple ingress, right, or services against a single load balancer. Because the way it works now, if we create another service, right, AWS will provision a new load balancer for you, and those things are not cheap, right? They are costly, right? So but there are ways where you could use a single load balancer, to map into multiple services. All right, so thank you for watching. Hope you learned something. Please don't forget to like and subscribe, and we'll see you in the next video. Thanks.